Go. Fantastisch. Stop socializing. Thank you. All right, that looks about right. So there's only one more hurdle between us talking about Swift. To give it one more minute. Jon is going to come up and do a talk, 15, 20 minutes or so, which it's about modularity, I guess. And I'm presumably not too much about the Taliban, but probably more of the former than the latter, I'm guessing. And then we'll do the panel discussion. So without further ado, Jon Sterling.
Can people hear me? Yeah, I don't know how to operate this thing.
Machines.
Yeah, machines, it's too much for me.
We'll set that to a height you're comfortable with.
That looks good to me.
Just testing you. Good Lord.
Okay.
I write software, I swear.
Yeah. All right. Well, hello everybody. So this ridiculous title, Modularity a la Taliban, is sort of like the characterization that has been made at my workplace, partly in jest, partly in complaint, of certain practices that I've adopted. And today I wanted to both defend that and also offer an alternative to some of the things that have been going around. So this is more how I feel about it. In the reality-based community, we have been doing modular design for about 25 years. And this is something that is not new. It's not something that we need to reinvent for Cocoa. Just it's very much a thing where there's a lot of prior art that we can draw from. And so I wanted to talk about two things, basically. Start off with sort of an extension to model view, view model, which allows you to support pure view models. And then the other thing I want to talk about is how to properly separate your signatures from your structures in order to have a truly modular design where if you wanted to, you could have your view models in one library and your view controllers in another one. And then how to glue all this together with RAC or whatever compositional events framework you're using. So my first realization was that MVVM is not enough. And the reason I say this is that if you look at typical MVVM code, what usually ends up happening is the entire state of your view is bound to mutable properties on your view model. And we do this because we want the view model to know all the things it needs to know, to be able to ask all the right questions, and then determine what it will do next. Sure. So MVVM, Justin was asking like a brief overview of that. MVVM is where instead of MVC, we have a model, a view, and a view controller. MVVM is where you have a model, a view, and a view model. And typically the view includes the view controller aspect. That's at least the tradition that I've been working in. And then the idea is that your network requests, your I/O operations occur in the view model, and your view controller exists to glue all that together into things that are presented in your view. So anyway, let's have a look at an example of code that you might find in like a README or tutorial for MVVM style work. So your view has like a text field, and your view model has a mutable cell on it, a reference for whatever got put into the text field. Like let's say we're making an app where you type a message and then you hit submit and it does something, and then you have a button on your view, and then we hook that up to an action on your view model. And then what happens is in the view model we implement this action. by reading from whatever the message was at the time the button was pressed, and then we enqueue some request, right? I'm using Rack 3.0 here just because I'd never used it before and I wanted to see what would happen. Whatever you end up using, you'll presumably have signals, bindings, and like some concept of a function, and so all these things reduce down to those, so it doesn't really matter what version of Rack I'm using. Go ahead.
So like this would be a command in 2.0, right?
Yeah, so Josh was asking if this would be a command in 2.0, so indeed Rack action in 3 is the replacement to a command, and then God knows what will happen to that like in the next few weeks. But the idea is that the when the button gets pushed, it sends an execute message to this action, and then it runs, and then the body of this block here is run. And so there's a few problems with this. We failed to differentiate state from input, and I think that's actually a really important thing, right? So what the user's typing in, that's not state, that's input, right? State should be the least information that you need in order to decide what you're going to do next. And we don't need to know. We don't need to know at all times what the user has typed in. And if we do, we should make those connections explicit, not by reading against a property, a mutable property on a view model. And a view model is supposed to be the functional part of our program. And to have it be mutable sort of ruins our ability to reason about state transitions. And so it turns out that we can take this interface, which was what the interface to the old view model was, and we can change it a little bit, and I'm sure many people have done this already in their view models, and simply get rid of that property and then make this action a proper function. And yeah, you'll see these type annotations. It's just a comment, but the idea is that the action takes, in this case, the action takes like nothing in particular as its input, and it yields something abstract, that is something that we haven't specified in the interface. And then here we've changed it to be an action that takes a string and then yields something abstract. And so then we'll implement it a little bit differently. And so in the view controller, now we'll actually thread the user's text input into the action. And because these signals are lazy, we can sort of build up a wire program like this where we say, like, when this happens, take 1 from the user's input. And then as a result, we don't have to actually talk to self anymore inside the body of this action. We can just use its input. And very much I see a view model as a thing which exposes a bunch of entry points at which the view can send it messages, and in this way we don't need to write and then read. We simply react. That was okay. Like hashtag react. So this is a minor change, but it actually it gives rise to a very different kind of design. If we start from sort of this like very Puritan idea of not having any mutable state exposed on a view model, then we'll end up when we do need to have actual state, we'll end up, like let's say that the view model is accumulating all the messages that was sent or something. We need to have a way to do that, and we need to do it purely. And so what I am doing is instead of having like a state property or something, I bundle up all the state that I could possibly care about in my view model, all the things that I need in order to decide what to do next, and all the things I need in order to know what to show on my view, into a particular object. For this program, it's called messages state, and then I expose it as a signal. And it's my responsibility as the implementer of this view model to thread all the information that comes in from the commands, right? And so the actions, and the actions are the only way to get information into the view model. It's my responsibility to thread all those inputs into something that results in a coherent stream of states. And there are a number of ways to do that. So here's our messages state object. It has this, so you can ask it what messages have been sent, and then there's one like basic version of it, one that has no messages, and then there's a way to create a new one that has another message in it. And so we've simply exposed state transitions on this object, and they're pure, they're immutable. So these create new objects. You're not actually changing the messages. That's read-only. And not only read-only, but also immutable. And then this gets a little bit tricky, but what we can end up doing is having the body of this action, remember there was that underscore which meant that the output of the action was abstract. Well, this is what it actually is. It's going to be, we'll perform this action, and then we'll describe what that action did to the state, and so that's modeled as a function from state to state, and so in this case, the output of this action is going to be a function which takes some arbitrary state and then adds this message to it. And then the idea is that somebody, I guess me, is going to have to thread all those together into this coherent signal of states. And then we can actually do that like this. You simply scan across all these transformations. Remember, the output of the actions is bundled up in this results signal on the action or the command, and all we have to do is scan across that, starting with an empty state, and apply each state transition one after another to the result of the previous one. So if you visualize it with my hands, it's like shoop, 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 and that's sort of how it goes, and then we expose that in the interface of our view model. And then all we have to do is, like in our view, let's say we wanted to present like a log of all the things that were done. We simply just have to observe the states of the view models. Now we don't have to do any reading of properties anywhere. It's all threaded through very explicitly in such a way as we can reason about these things as pure functions on signals. So that's the purity aspect of this, and the composition aspect. The other part I wanted to talk about was the how to use this to make a truly modular design. We've already had one big win, which is our ability to separate to separate two different things, right? The view model, which is sort of a notion of inputs towards state transitions from the view itself. These are so that's already pretty modular. But what I've realized is that there are aspects of each thing that the view controller doesn't need to know about. And so, for instance, the view controller does not need to know how to create a view model. View controllers should never be creating their own view models. If you're doing that, you're doing it wrong. What you should do is initialize your view controller with a view model, and view models are only ever born from other view models, right? And so in that respect, the view controller really only needs to have like a basic idea of what it requires from its view model. And the view controller also doesn't need to know anything about the model's states except what questions it can ask them. It needs to know what are the messages that have been sent, but does not need to know how to create a new state based on a new message. That stuff should be a secret. And so the result of that is that we should be breaking these things up into different signatures, and then we can, at different entry points in our API, we can expose these objects like opaquely ascribed with a more restrictive signature. And so the first signature is the state, which is simply the ability to ask the question, what are the messages? And then we have an object, an implementation of this messages state signature, which describes how to create states and how to transform one state into another state. And that's totally orthogonal from what it means to be a messages state. And this is a secret that it's known only by the view model. And so in fact, you could put this implementation local inside the view model's file and no one would care. And your view model has a similar issue where the only thing that anyone except for the view model itself needs to know about is what are its inputs and outputs, the actions and the signals. And the view model itself, the particular implementation you give it, how you initialize it, all those things, that's the responsibility of the parent view model, right? Anyone should be able to construct their own version of it so long as it can be ascribed this signature. And then as a result, the view controller knows nothing about the view model class except that it adheres to this signature. Okay. So I would like to give sort of an overview or a demonstration of what it would look like to design something in this manner. And so the other day I made like a little Tic Tac Toe app. going to make this full screen now. Okay. So I'll sort of just start from the beginning to just describe like how one would architect something like this, and just if that's helpful. So the one exception to the idea that view models only ever create view models and nothing ever creates a view model except for that is the app delegate. That's one place where we we set the ball rolling, and so we'll make a view model here, and it's just that concrete class, and then we'll put it into a view controller. But from then on, view controllers know nothing about view models, and view models can be considered entirely separately. So let's have a look at our interfaces quickly. So the view models interface is similar to the one that we were dealing with before. So we have a way to play a tile, and we have a signature, a signal that tells when someone's won, and then we have this little like state machine thing, and this is that like folding up of state transitions into states. And a state machine here, it's just something that exposes states, a signal of states, and a signal of transition errors in case you make a transition that's not possible. And it doesn't matter how you implement this, right? But in the view model itself, we'll actually go and implement it using an auxiliary object. And so this state machine, we decided that our state transitions. Come on now. Our state transitions are functions from a state to a signal of states, right? Because when you play a tile, the computer responds by playing another tile, and so it's not. And so what happens is the state transition is I have an action, and then two things happen. First, the state changes to show that I played this tile, and then the state changes to show the computer played this tile. And so as a result, we need to compose functions of A to signal A. And so this Kleisli transform state machine is a realization of that idea. And it's an entire, and so here's like this nasty like scanning thing, and then there's like an auxiliary operator here, which describes how to fold that crap up. But it's not really important, because all the interface knows about is that it's got like some notion of what the states are. Okay, and then we have another protocol for like the state. So we describe what questions we can ask the state, what kind of concrete data are in there, but we don't actually implement it. And it's the responsibility of the view model to provide an implementation. And the view model provides this particular implementation, which has an empty state and it has state transitions. Right. This is a function. This is a function from self, the current state, to a signal of states that are brought on by this extra data, and we implement it like in the usual way. And all this stuff is tucked away. And then the view controller knows only about the questions it can ask the view model, and thence it knows only about the questions it can ask the view state. And then we hook everything up. In the view model, we construct the view, we bind the actions to the view model, and note that we don't like have some like property like last tile played, or we don't do anything like that. We don't have a different action for every tile. We put it as the input to the action. Because all it is a function from A to signal B, and we use post-composition to make that work. And now we have a program, and we can actually run it, God willing. And yeah, it's a live demo. So. And so now we have a game, and it's not that great, but the idea is that this was nobody won. Okay, it was pure functional though, and so now we have the ability to reason about every aspect of our program separate from every other aspect of our program. We also have the ability to take our entire tower of view models and concrete view state implementations and put them into one library and have everything else in another library. In fact, there could be there's something really special about that. I mean, in the case of the app that I'm working on at work, it's pretty large, but I could take it and have like a static library which represents all of the view models, and it would be entirely fine to create different views from it. So that's like the classic MVVM promise actually realized. And on the other hand, it's all pure functional, so I can actually reason about it and understand what it does. So that's why I consider this to be even if it looks like it takes more code, it's the kind of code that I can just sit down and write. Like I can just spit it out without having to think about it too much, without having to think about like, well, have I proved that that like, you know, when I access this other thing hasn't changed, right? No, because I have a single coherent pointer to the state because I'm a function. I'm not actually reading from self. It's not like I have to worry about like self.state here, self.state there, and then if anything changed, I'm screwed. No, it's all functions. And that's why programming with functions is indeed a simpler way to do things, even if sometimes it makes you write more code. That's all that I wanted to show you, but I'm happy to ask you answer you any questions that you may have. Okie doke.
Can you rebuild a tract action for me?
Like right here? We'll save that for another time. Okie doke.
So I mean, pragmatically, it looks like avoiding capturing self strongly is also an immediate benefit in that you're not hitting reference cycles. This is something I've been frustrated with in my own use of signals. When I'm capturing self strongly, usually I could be throwing this through somehow.
You're right.
I mean, that seems like a kind of orthogonal benefit. I can't actually remember my question.
Yeah, I'll try to repeat what Rob was saying, which is that another sort of side benefit to this technique is that there are many cases where previously you would capture yourself in order to read its state, or God forbid even to write its state. Good Lord, and when you when you do that, you end up having to avoid a retain cycle by making a strong reference on the outside of your block and a weak reference on the outside and a strong reference on your inside. I mean, yeah, even I get that wrong, and. I would say that when you're doing that, it's a really good sign that there's a more compositional way to go about it that will, on the one hand, be easier to reason about, and on the other hand, will make it so you don't even have to worry about these retain cycles. I would say that if you're at risk for a retain cycle, there's a really good chance that your design is not correct.
I remember my question. Does that abstract to anything you're capturing, like closing over rather than taking as a parameter?
So Rob's question was, does that abstract to anything you're capturing as opposed to receiving as a parameter? I'm not really sure I understand.
So anything that your block, anything you're closing over that is like an underscore block reference. So something that might be updated rather than I'm just using some parameter.
I mean, I think you shouldn't do that, is what I would say. Okay. All right, good. Thanks for listening.
All right, we're going to take like 10 minutes or whatever to set up the panel up here with some coffee chairs so you guys can go off and have a drink. Is there still coffee? Or hang out here, it doesn't matter, but we're going to take about 10 minutes.